Hello everybody and welcome to Combustible Dust. This is going to be our video on this explosive topic, if you will. And we're going to have some fun demonstrations at the end, but we got to go through a little bit of the knowledge and the theory of it first so everybody can understand exactly what we're talking about. Alright, so at the end of this video, you'll be able to identify sources of dust explosions, how they occur. You'll be able to identify best practices to control and eliminate the buildup of dust. And then, more importantly, you'll be able to apply knowledge of those best practices to the everyday cleaning of facilities. First things first, what is combustible dust? Well, combustible dust is a particle that is small enough and fine enough that can be combusted in the air. I don't know if that's the right phrase for it, but it can turn into a combustible explosion when it's surrounded by air and is dispersed in the air because it's so fine. And it's formed by processing materials, whether it's sawing, routing, cutting, grinding. It doesn't just have to be wood. It can be metal. It can be flour or grain dust, things of that nature as well that we don't necessarily process here in our facility. And it's an issue because since that dust is so fine, and as it gets airborne, it can eventually settle on top of things, rafters, other sprinkler head pipes. It can set onto ductwork, and it can create a buildup, and then that buildup becomes fuel for a dust explosion. And so here we have two different charts of what a micron is. And a combustible dust particle is combustible at 450 microns or less. And when you look at this right here, you can see coffee ground, beach sand, all this stuff. You want to look at a human hair. Everybody can kind of gauge the thickness of a human hair. And then when you go all the way down here, you see micron. That is very, very small. But again, you're thinking 450 of these microns makes up a combustible dust particle. This chart over here does a great job of visualizing it as well and giving more industrial examples of combustible dusts and when they become combustible. So 450 falls right about here. And sand is a good example because you can still see sand with your eye, but it can also be small enough, just how sawdust can be small enough and fine enough that it creates that hazard, but it's still big enough for you to see. So just because it's combustible doesn't mean you can't see it, and that doesn't take away that hazard. The hazard is still there. Here we have 4 different examples of different particle sizes that we can use. Then table saw, this was taken from underneath of the table saw where the overhead dust collection did not pick it up. And it's important to understand that because a lot of times the finer dust that doesn't fall underneath, that gets carried up into the air by the saw blade, is that finer dust. And you can see that there's some chips, there's some shavings in there, but not as much as compared to the planer. These two things, these two piles of dusts, they will more burn than explode. And the two piles below it, solid surface dust, and then the lycopodium powder, those are very combustible, and almost any situation where they're put in with the right products will result in an explosion. Whereas a table saw, you have a little bit of the dust that could be small enough for a dust explosion, and you have a little bit of the dust that is a little bit too big for the dust explosion. But before we get into the whole explosion videos and all that stuff, we need to understand what combustion is, what fire is, and how that all relates to everything. And right here you can see the combustion triangle. It's simple. To get a spark or a flame, you need 3 things: oxygen, heat, and fuel. And it's important to know, as I'm sure many of you know, when you take away one of those items, you don't have that flame, you don't have that spark. Clearly we can't take away oxygen, but we can take away the heat, and we can take away the fuel. And whenever you take away one of those things, you eliminate the spark or the combustion or the flame from ever happening. And then taking it one step further is this, the fire tetrahedron. And this is what outlines how a fire is formed and fueled. You can see, you have oxygen, heat, and fuel, but the important thing to note, and what separates this from the combustion triangle, is that chain reaction. Without that chain reaction, you don't have a fire, you just have combustion, you have that spark, you have that flame. But to sustain that flame to create a fire, you need that chain chemical reaction. And again, it's the same thing. When you take away one of those sides, you take away the risk or the possibility of there being a fire. And that kind of segues into this dust explosion pentagon. Obviously, with the pentagon, there's 5 sides, and you want to take a look at the 5 different sides that it is. You can see some similarities between this, the fire tetrahedron, and then the combustion triangle as well, but this is truly unique in itself because you can control a lot more of this than you can of the other 2. And one of the things that we have to keep in mind in a facility that has this potential hazard is that you can't take away the oxygen and the confinement. We're in a building, we can't take away that. Even though we have some garage doors open in the summer and we have some doors and windows that we open, you still can't take away that confinement. But you can eliminate the ignition source, you can eliminate dispersion, and you can eliminate the fuel. And I touched base on this a little bit with the different piles of dust that we have. One of the things that you want to keep in mind, and it's really important that everybody knows, is the surface area. How does the surface area impact the probability of an explosion? And it's thinking back to those planar chips and those planar shavings versus the solid surface or the lycopodium powder. And it's that surface area. The bigger the surface area, it'll still burn, and it can still be combustible, but it's going to take a lot more to combust. It's going to burn before it combusts. Whereas something smaller, where it has that surface area, it'll be a lot easier to combust it. And we're going to take a look at this cube right here. It's a 2-inch cube, which means 4 square inches on one side, and there's 6 sides per cube. So this cube right here has 24 square inches of surface area around it. What happens if we make it into 1-inch cubes? Cut it there, cut it there. We make all our cuts, and now we have 8 different cubes. Well, now each cube is a 1-inch cube, and each side is 1 square inch. But we still have the 6 sides per cube and 6 square inches on the surface area, so each cube has 6 inches of surface area. Well, you think, okay, there's only 6 inches per 1 cube, whereas there were 24 before. But then you have to think about that we made 8 more cubes, and now we have 48 inches of surface area rather than just 24. So essentially, we double the surface area just by making 3 different cuts to form 1-inch cubes. And again, this is just with cutting. This isn't with sanding, this isn't with grinding or any other processing. This is just with cutting. Imagine when you're taking material and routing it, or when you're sanding it, and the amount of dust that comes off of that are microns in diameter, not necessarily 1 inch in size. And that's where we want to look at, because that's where the hazard truly lies. I talked about the controls a little bit, but I just want to reiterate the fact that we can only control so much with our industry and our environment here in our facility, or in any facility for that matter. To get the flame or the spark, you can control the heat and fuel. You can eliminate both of those. Now, obviously, working in a woodworking shop with the general industry that we fall in, or even construction, you can't eliminate the wood from our production process. But what we can eliminate is a buildup of excess material that is fuel for those to start to have that spark or to have that flame. And then obviously with fire, it's the same. Take away heat and fuel, and then firefighting if needed to take away that chain chemical reaction. And then for an explosion, we want to control the ignition, dispersion, and fuel. And that means not using the compressed air to blow off your bench, sweeping it instead, brushing it off with a hand broom and then vacuuming it up at the end of the day. We're going to talk more about these controls in our dust explosion plan that we have. Through IUP and through the PA consultation program, we met with the consultants and we identified dust explosions as a hazard that could impact our company. Even though there's the National Emphasis Program, we worked with them to create a program to completely mitigate and control the risk of us having. And it's a multi-year program, and that's what we're going to focus on over the next couple of years. We're going to focus on the eliminating the different sources of those 5 sides with that fuel, the ignition, and the dispersion. If you watch the trailer that I created, I ended it with what could happen Safe and Sound Week 2020. And this is essentially what can happen. I want you to take a look at this. Both of these videos that we're going to see were shot in slow motion, and I am going to comment on them in between just to kind of give you guys a little bit more context behind it. Let's see here. This is the first one.
Ready? Yep.
As you can see, let's wind it back a bit. There we go. In this box, we have all 5 sides of our dust explosion pentagon. We have the confinement, we have our ignition source, we have our fuel, we have our dispersion, and obviously there's oxygen because the candles are burning. And this is a small scale representation of it, but I'll let you. Oh, I didn't want to do that.
Ready?
Let's watch it and then I'll comment more on it. That is something that could happen with our building and our facility. But whereas the newspaper flew off the top, that could be a door, that could be a roof, that could be machines flying. It's a very catastrophic event that is very easy to prevent. And then video number 2. So again, you can see the ignition source catching that fuel on fire and it blowing off the newspaper. You can see it catch all of the fuel on fire. And then you see this little backdraft. That was all of the uncombusted, non-combusted fuel that was dispersed in the air. And as it comes back in, that's very similar to a secondary explosion that we could have in our facility. If we would have an explosion on one end, it could knock dust loose from the rafters or the ductwork on the other end of the shop and then create a secondary explosion. And you can see as I play through it, the newspaper caught on fire and you can see the fuel is just continuing to burn. And that's something that could happen as well. Not only could we have the first explosion, a secondary explosion, but we could also have a fire that is associated with it. All in all, with a dust explosion, building go boom, and it's not good. As always, if you have any questions, comments, or concerns, send them to our new email, safety@giffininterior.com. Only I can see this email, anything that comes in, and it is 100% confidential. And if you don't want me to know that you have a concern, you can always tell a value stream leader or a safety committee member, and they will relay that back to me without mentioning who brought it up. Thank you for watching our video on combustible dust, and as a reminder, think safety, work safely.